Hello everybody and welcome back to another visual pattern challenge. We've got a strange one today. Here's step 1, here's step 2, here's step 3, and your challenge is to predict the number of squares in step 4. If you can do that, can you predict the number in step 43? And can you write an equation that could be used to predict the number of squares in any step at all? So that's the challenge. If you'd like to accept it, pause the video and see how far you can get. All right, this looks like quite a big monster of a pattern. It's definitely getting big pretty rapidly, so I've got to guess that this is going to be a quadratic, but how do we even approach this? It looks kind of complicated, and actually the numbers look really, really big, so I'm not even sure I want to start counting the squares right now. Let's see if we can just sort of break this down into pieces and get some visual intuition about the pieces. Um, So the first thing I notice is this little guy right here just seems to hang out every step. So that's like just one that doesn't change. So that's going to be probably a +1 in the equation. And then what else have we got? So we've got these squares. It starts with 4 2x2 squares, and then we have 3 3x3 squares and a 2x3 piece. So it looks like this little, like if this is a leg, this leg is different from the other leg. And it looks like these 3 squares follow the same pattern. So they're 2x2, and then 3x3, and then 4x4. So I would guess in step 4, I would have 3 5x5 squares. So these would be 25 squares each. And then what about this other leg? So first it's 2x2, and then 2x3, and then 2x4. So what I expect is this is going to be 2x5. So that's another 10. And then we've got this 1 hanging out here. And I think that would be it. So 75, 85, 86 for step number 4. So that's my guess about step number 4. And I think rather than counting the numbers here, I'm going to move towards an equation just from the visual intuition that we've seen so far. These 3 squares, they start at a 2x2 square. That's 1 more than the step number. And then they go up to a 3x3 square. That's 1 more than that step number. Then 4x4, 1 more than that step number. So I think one of those squares would be x plus 1. So that's the step number plus 1, quantity squared. But then we have 3 of them, so we can multiply that by 3. So this expression should cover this set of 3 squares that keep growing. What about the other leg? We've got 2x2, 2x3, 2x4. So it's always, I'm going to put a plus here, 2 by something. And the something, it's 2, and then 3, and then 4. So it's 1 more than the step number. So that's another x plus 1 here. And then we've just got this leftover 1, so that's our plus 1. So I think this is our equation. And let's see. I'm going to let you, since I'm running out of room here, I'm going to let you FOIL all that out and combine the like terms on your own. I think this equals 3x squared plus 8x plus 6. And if you want to count all the squares here and analyze the numbers, since this is an x squared, we wouldn't find a constant in the first set of differences. In the second set of differences, we should get 6. So you can verify that this might be right. But I think this looks correct. And it goes with the visual intuition, but let's just test it in a couple places. So this would be 3 times 1 squared plus 8 times 1 plus 6. So 3 plus 8 plus 6 would be 17. And what have we got here? That's 16 plus 1, 17. Yeah, that looks right. Let's just try one more. So 3 times 2 squared plus 8 times 2 plus 6. So that would be 12 plus 16 plus 6. So 34, it looks like. And what have we got? 27, 28, 29, 30, 31, 32, 33, 34. Yeah, so this equation seems to be working out. So I'm pretty happy with y equals 3x squared plus 8x plus 6. And then to get the number in step 43, we're just going to plug in 43 for x in this equation. It's going to be quite a big number. So we've got 3 times 43 squared plus 8 times 43 plus 6. and let's see, I'll keep working over here. So 43 squared is 1849. Multiply that by 3. And let's see, 8 times 43, 8 times 4 would be 3, 8 times 43, 20, and 8 times 3, 24. So 344, and a plus 6. And let's see, 3 times 1849, that is 5547. And then we've got plus, we'll add those together, 350. So I'm getting 5897. You might want to calculate that yourself and see if you come out with the same number, but that's what I'm getting. Well, how did that go for you? Kind of a monster of a pattern here, and definitely a big number for step 43. I'd be interested to know, did you come up with this equation? Thanks, everybody.